I mean, clearly that's been part of the discussion, and we've had
A little bit of Seattle trivia. We were talking a little bit at breakfast. I guess the next question, how many people have seen the Pike Place Market downtown? Well, looks like almost a good percentage of that. Did you get to see them throwing the salmon? Okay. That was a question of, came up this morning. What's the idea behind that? I think it's just to get themselves on the map, the one seafood market there, but they play it up pretty good when you got people coming in, and they'll at times throw the foam fish. I don't know if you saw them throw the foam one. They'll fake people out, throw it to people in the audience, and they'll throw a foam one as well. But I think it's to try to get their seafood market on the map, and a little bit of excitement going with the crowd. But a little bit other. Oh, anybody have any problem finding Starbucks? I'm just kind of curious because there is, I think, still they may have changed it. There was actually one intersection in Seattle that had a Starbucks on 3 of the 4 corners of the intersection. So I got to admit, Mr. Schultz is getting his time in Seattle. But another thing about the Pike Place Market, did you realize that the very first Starbucks is there on Pike Place? If you come down and you go through the market where it kind of terminals to the north, if you haven't seen it, that's the very first Starbucks store. A lot of people going there to get pictures and obviously get some caffeine. All right, so I've got a little bit our presentation to give to you. I've been asked to talk a bit about the lessons learned or the benefits we've realized from using asphalt, modified asphalt. So we'll get into that a little bit about products and processes, some of the case study work that we've done here in Washington, and kind of where we've been and where we are now and where we'd like to get to in the future. Here's a bit of a test for everybody. Since you've been to Pike Place Market, can anybody tell me what this is? This is one of the, I guess, tourist activity or a tourist attraction. This is the gum wall, where up until November of last year, I think it's been about 20 years, people have been going down to, when you first walk in off of Pike Street, as you cross First Avenue, if you actually go to the left, you'll see a little bit of a road that tapers down below the market and then hooks to the south. That's where the gum wall is, in case you haven't seen that. It's not in that condition anymore because in November of last year, finally the local businesses and a few of the folks and the residents of Seattle petitioned and got that removed. They removed 2,350 pounds of bubble gum off that wall. I don't know, maybe there's an opportunity for a modifier there. I don't know if anybody's thought about that, but just a little bit of information. Anybody traveling with kids? Not too many hands. Well, that's good, because you wouldn't want to take your child down there. You also may come away, if you did have a child with you, if you noticed they weren't chewing gum before they visited the wall, you might want to pay attention to afterwards. So. All right, well, I guess time to get into the fun, exciting stuff of asphalt. Just a few facts about our agency, though. After the presentation given earlier, Washington State, a year ago, we were in pretty dire straits. We didn't have much in the way of funding. We didn't have a budget package. We were getting to that situation, as Delmar talked about pavement preservation, that type of thing. Our pavement management system, we were looking at enough money maybe to get out and pothole patch and maintain our highways. Well, fortunately, at the end of last year, thankful taxpayers and the politicians in our state were able to pass a budget through our Connecting Washington package, our transportation package. It is a 16-year, $16 billion package. Of note is that $9.7 billion for state and local roads. We also have $1.4 billion for highway maintenance, operation, and preservation, and that's going to be phased in over 2 years as a gas tax, 11.9%, or 11.9 cents per gallon, I should say, for the next 2 years. A little bit about our agency, some facts. We manage approximately 1,800 or 18,500 lane miles. It is our charge, our duty to maintain or to build and maintain smooth, safe, and economical pavements. And a little bit about our forecast. Our construction office does a very good job of predicting and tracking what our projections are from year to year. This is our 2016 forecast. We anticipate a little over 1 million tons of HMA placed. In my 30 years with the agency, I've seen, I think our record year was just south of 300 million, excuse me, how about 3 million tons? 300 million would be quite a deal. But we've had up to just close to that, but I've seen it as low as 600,000, and that's where we were getting to with our lack of funding until recently. We don't expect to see a huge change in our construction program this year. Starting to pick up a little bit more next year, and then as we start moving into and getting the funding, we'll be getting more projects placed out there. And of that, a little over 1 million tons, over half of that is anticipated to be built with modified asphalts. This is a chart that again, our construction office maintains, where they'll graphically show the tons awarded. Let's see if I can find the laser. Yeah, where we're talking about the tons anticipated for the year, and then as they're allocated or as they're awarded. There's a website address there. I have it on my very last slide if you're interested. One thing they do a good job of is not only tracking the total quantity of HMA in the state, it also tracks the tons of liquid and where that's going to be used from a regional standpoint. We have 6 regions in the state. So that might be of interest to those of you in our state or in our market, in our area. Okay, a little bit of background about how we got to where we're at. It was through the super paver sharp efforts. We got into the pooled fund studies in the mid-90s, and we started working with, obviously, the PG binders, performance graded binders first. We had a lot of, while participating in the pooled fund study, we started placing test sections on projects, and then ultimately worked our way up into trial projects with the PG graded asphalt. Our first PG graded asphalt trial project, I think, was in 1996. And then we fully implemented the PG binder system in 2000. Actually, it was 1999 is when we implemented it, but you didn't see it in our print of our specifications until 2000. And then as we moved into super pave, we did the same concept. Trial projects or test sections, then trial projects, and ultimately implemented super pave volumetric mix design in 2004. And a little bit, I guess, over the years, the things we've learned are the importance of asphalt and asphalt anastrip compatibility. We also understand and learned quite a bit about the asphalt modification, what I call the products and the processes used to modify asphalts. And then what we've at least realized, the benefit from some polymer modification. I'm trying to combine that into one word. And we learned a lot of this primarily through use of our Hamburg and our multiple stress creep recovery testing. And as a footnote, we've been testing using the Massacre, well, long before its T350 test procedure, or M332. We started testing early on after we saw D'Angelo's work, and we were doing it when the temperatures were still elevated. But every binder that we get in our door at the DOT, we've been testing in conventional M320 as well as M332. So we've got a lot of data. We've learned quite a bit about at least the asphalt binders we have in our state. Okay, on to the Hamburg, or Hamburg. I used to say Hamburg, but then I suppose since I was born in Germany, I should pronounce it the way that they would, which would be Hamburg. Okay. We don't have the Massacre currently, and I'll get to that. Good question, but we really hope to, and I'm just going to, later on, I'll talk to kind of a plea to everybody here about what we'd like to see done in Washington, and we seem to be at least the only state in our region so far that's pushing hard into that. With the Hamburg, we bought our first Hamburg in 2010, and once we got it, we started testing every mix design we get in our door. On average, this year, for example, with the little over 1 million tons, we're anticipating somewhere between 80 and 90 mix designs in our doors. So we've got a lot of data that we've tested with HMA using our Hamburg. And this is the type that we have. We have 2 of the early editions of the PMW Hamburgs. I like that little thing in there where it says it shown with optional crane lift, and it's kind of one of those batteries not included kind of ideas, but that is an expensive upgrade on those things. But I believe Troxler now has the marketing rights to this particular type of Hamburg. Okay, and we do have 2 now, by the way. Imagine our excitement when we saw this. 2010 is when we started testing every one of our mix designs. And if you know anything about those, we set it and forget it, and you come back with 6 to 7 hours later. And this is one of the early mix designs we tested, and what we believed through our Veeam stability mix design was a good product. And typically what we do, we'll test the left side with no anastrip, and we'll test the right one with a liquid-based anastrip if it's needed for this mix design. So this was an enlightening opportunity where we had a material that met every one of our specifications, but yet we see this when we get done running it in the Hamburg. Here's another nice one. Anybody see silty fines? So these are the type of mix designs, not everyone, but we were seeing somewhere in the neighborhood of maybe a dozen of those, say 80 mix designs. And that's a pretty high percentage as far as we were concerned, where we were seeing questionable or concerning results out of Hamburg. I got to do that. I got to convince myself. Okay, as I mentioned before, a little bit of background. This is our state. We use what I call a modified allotment process. And that's because we took the T283, and again, because of the sheer volume mix designs we evaluate through the year, we don't do the 3 replicates at every point. We do a single set. So that's why we had to do our secondary modification of that. And you'll see as we test in our Hamburg, we'll always test a sample with no anastrip. We'll also test samples with anastrip based on what our modified allotment procedure tells us. So if we see a benefit in tensile strength, and or if we see any stripping with no anastrip, we typically would move to using quarter increments of a typical amine-based anastrip. I think nowadays we have somewhere in the neighborhood of 24 different anastrip additives on our QPL. So you can imagine it's quite a thing to manage, or to say that we're using the same materials in every one of these mix designs with the binders. This is a conventional half-inch HMA mix design that we tested in 2011, where we, by the way, this is a neat asphalt. This is 64-22 half-inch HMA. When we ran it through our modified, I'm going to keep saying modified, we ran it through our allotment process, and we saw a benefit by using 1/4% anastrip. So as we tested it, neither one of them looked excellent, but graphically, here's what that looked like. And we did see a benefit from using anastrip, and if you fast forward, the specification we're using for Hamburg would have failed with no anastrip because we have 10 millimeter rut depth, and it has to have a maximum or a minimum of 15,000 passes. So you can see here we were able to get this particular mix design to pass under what we use as a specification by use of anastrip, and this again was with a neat asphalt. Okay, here's where things start to get interesting for us. In 2011, we started noticing a trend. When we tested this particular HMA, another conventional mix, with what we expect to be a modified asphalt, I mean, we have the two together, that's 92, 64-28. When we tested in our conventional moisture susceptibility test, we saw a benefit by using 0.5%. We had an optimum tensile strength at 0.5% anastrip. When we mix these two products, you can see the results, I think, just by the picture, if not by the graph, that when we added anastrip, it was detrimentally worse. We saw significant rutting with this. You don't see in the picture that we had any stripping, but we definitely saw something happen in what we consider to be an indication of compatibility with asphalt and anastrip. In our state, we don't get into formulation. We don't dictate what it takes to meet the specification. We try to rely on our test procedures and our specifications to get the products that we know will perform. So this is what we saw. And this was not the only mix design we saw that this happened on. So after we saw this particular mix, we did our due diligence. We went back and started analyzing the data we had. We not only test every mix design that comes in the door, it met all the volumetric properties, but we also test all of our asphalt binders. And those asphalt suppliers that are here from our state know when we're working on our mix designs, we come to you directly. We get 40 quarts of whatever grade of asphalt it is. We test those just to make sure they're in specification, and we use those materials in our mix design analysis. So this particular mix had no problem meeting the M320 specifications. And again, when we tested by the allotment process, we showed that improved TSR, as I mentioned, at 0.5%. And the Hamburg just said there was a compatibility, well, we believe it's a compatibility issue. And that's about as far as I want to get into the compatibility, because I'm not the chemist. I think there's a lot more people in this area, or in this room, that can probably tell me much more about that. So the particular asphalt supplier that provided that product was very forthcoming. We contacted them and asked them a little bit about the formulation, told them what we observed, and they said, well, no, it was not a polymer modified product, but it was modified. And that's as much as we wanted to hear. But they did offer, and they did provide to us, a 64-28 that was polymer modified, and this is that exact same mix design with a polymer modified PG 64-28. And the results are pretty much on top of each other with no anastrip. That's very consistent. Kind of a stack of the two, that's what we saw. Again, this is the same material. The only difference is the binder. So when we started looking at what we had coming in the door for our typical modified asphalts, and well, we use 6 grades in the state, but everything we're getting in the door, we have a very, very low failure rate of asphalt binders. Everything we're getting in the door is able to meet M320. We have been, again, testing per M332. We've been testing these products and they have been meeting the JNR and the other specification requirements of M332, excluding the table, the appendix, the table in Appendix 1, or X1 that is. And in addition, once we started seeing this back in 2011, we started testing these materials per AASHTO T301 using elastic recovery. We were resistant to be a plus spec state. We've just been marching the party line with M320. We used to be in AR4000W state, and we had a little enhancement on our viscosity graded materials. And in Eastern Washington, where we have the bulk of our modified asphalts, we used to use a lot of PBA6. When we went to M320, there's no mechanism there. The modification products or processes we're getting were probably not very similar to our PBA6 in order to meet the M320. So, a little bit of information. These are the two binders that we did that little experiment with. I already mentioned they both met M320. They both met M332, except for the one on the left, the original formulation wouldn't meet that percent recovery table in the appendix. And when we tested it per T301, you can see what we got, 25% on the elastic recovery. With that new product, we were able to meet not only M320, but the table. We met the percent recovery, and we got a substantially higher number on the elastic recovery. I'm sure you can see these values. So, just a graphic. We put this is just a plot on that curve. This one actually is plotted in the right area. You can see that what the results we got. It more than exceeded. In this case, the 6428 on the east side would be what you would call an S grade. So the JNR would only be 4. Well, it far exceeded that. It was more than able to meet that. We had a JNR of 1, and the percent recovery on this one was 33.4. Yeah, okay. And that was on the M332. I was thinking elastic recovery, and I said that, but that's different. This one's not plotted in the right location, obviously, because this was tested out at 2.3 kPa or on the bottom, on the x-axis, and it got a 2.3. So, or I mean, it got a 4.6 on the percent recovery. So just give an idea where those landed if you were to plot them on that curve. A little bit, okay, so based on the couple of years of data that we collected off of the Hamburg and the massacre, we had to do something. We can tell we had to do something to make sure we're getting material that's going to perform. So we did go ahead and implement an elastic recovery specification based on the data we collected for those 2 years. Ultimately, as we move forward for the next 3 years, collecting information both on our Hamburg and IDT, we also implemented those specifications in 2014. The IDT specification we're really using as a bookend. The Hamburg loves stiff mixes, but we don't have an overlay tester like Texas or some other states. Those that are using Hamburg, I think, are all moving to something as a secondary check to make sure they're not getting some form of fatigue cracking. And with the equipment we had from the old static press from the Veeam days, we saw a benefit by moving into a room temperature, basically IDT. So we're using that as a check to make sure we're not getting too high a strengths on that, and we're pushing that spectrum a little bit too far into stiff brittle mixes. I'll talk a little bit more about that in a minute. And ultimately, as you mentioned, or the question earlier, we're wanting to move the multiple stress creep recovery. We've been working quite a bit with this, and I'll talk a little bit more again about that as we move along. Here's what our elastic recovery specification look like. As I say, our state is divided pretty much straight north and south by the Cascades, west side of the mountains. The 3 grades that we use on this side of the mountains all are -22. Our base grade is a 58 with the 2 bumps to a 64 and then to a 70. Our east side of the state is all -28 with a base grade 64, the first bump to 70, and then a second bump to 76. And that's what you see here with our grades of asphalt. We didn't implement it, obviously, on our neat, what we consider to be neat asphalts. We do have a 60% minimum on the other 4, what we consider to be modified asphalts. And this is a stopgap until we can get to something that we would prefer to do, which I think you know what that is. And this is our specification. These are all in our 903 standard specifications if you're ever interested to look at these. When we first got into Hamburg and did a lot of this initial testing, we relied heavily on what Texas did, Colorado was doing, Montana, Utah. Those are the 4 primary states that we gleaned information from, and Then when we went back and tested all of our materials for almost 4 years, actually, we came across what we believe to be a pretty fair and a reasonably easy specification to implement. So everything, as I mentioned before, was based around 15,000 passes with a maximum 10 millimeter rut depth. Again, with 15,000 minimum passes, you're not allowed to have any stripping inflection point prior to that, any indication of moisture susceptibility. And then we're using right now 175 PSI maximum for that IDT. I like to use this chart, which is a pretty picture of what you'll see out of the Hamburg. I wish all of those showed an inflection point when it happens, like as easily as that does, but they don't. You get in situations where it's very difficult to pinpoint that, and you're trying to do this visually. Well, we are working, I guess, or again with, there's information that we're kind of gleaning, I guess, from Texas A&M, Transportation Institute, TTI, Dave Newcomb, and those folks there, to mathematically see if we can come up with a better way to determine this stripping number, they call it, or stripping inflection point, whatever you would like to refer to it as, so that we can be more fair and equitable about how that, or when that takes place, so we're not trying to use a straight edge and come up to see where we can see a change in slope to determine moisture susceptibility. And again, you know, everything I mentioned before in our specifications, all around 10 millimeter maximum rut depth, and you can't exceed or that rut depth anything short of 15,000 passes. And in this one, obviously the stripping inflection point happened well in advance of that. And this is probably not the best chart to use, but it's the only one I had to kind of show you what our IDT looks like when we're running that in triplicate. We're using that ASTM D6931, I believe it is. The other thing we're doing, continued evolution of these specifications, we're looking at some work that Haifeng Wen has developed out of WSU. Rarely do I quote anything out of WSU because I'm a very avid Husky fan, but we'll give them a little kudos for the Goku's concept there. But they're working on that area under the curve or the fracture work concept, and we're looking hard at that to see if we can come up with a better way of specifying that instead of just saying a maximum stiffness of such, a maximum strength. We really need some dwell. I think you need some opportunity to see that those materials will be able to sustain a load. So we're working a bit on that. And I guess kind of getting to where we're headed next, to kind of back to the way to answer the question that was asked earlier. The multiple stress creep recovery is what we really want to see move forward. And we've been working with everybody and anybody that will listen to us. I'm on the Washington Asphalt Pavement Association task group. We're breaking out with some of the suppliers and working on this. We've been working with the Pacific Coast Conference. Pacific Coast Conference, I'm co-chair for the Massacre task group there. And a little kudos to Mike Anderson and Asphalt Institute. They helped us immensely to put together an interlaboratory study last year. I guess it's probably all 2 years now, Mike, where they took our results, plotted out, came up with what we had for precision bias, and I think our numbers matched up pretty well to what the East Coast User Producer Group I think there's 2 or 3 other ILSs that have conducted the same work. Yes, the reproducibility and the numbers are not where we would like to see them, but I guess the thing I want everybody to remember, when we went into PG binders, were those numbers, were those precision and bias statements, were those as good as you would have liked to see when we made that move? I don't think so. As a matter of fact, to this day, the PAV DSR is not great. I really wish that everybody would strongly consider this. I guess this is kind of my beating the drum and asking for help. We're looking for regional assistance. We're talking to other DOTs, our asphalt suppliers, and I guess I'd ask everybody in this room in whatever capacity you fulfill or whatever your role is in this industry to try to assess, to test these materials using M320 or T350 test, compare them to M320 to where we can get consistent and everybody get comfortable and move forward with this. I think the technology is there. The obvious advantage is it's going to replace these plus specs. I don't think anybody likes the various plus specs that are used around the country. And then ultimately, you know, it would require a new grading system. One of the first, I guess, concerns that we've heard from industry was what we're calling these materials. And I'll get to that in just a second. But as again, if you look at the current system, the flaw was that this was built around neat asphalt, unmodified asphalt. And I don't think this is anything new to anybody here. We've already talked, everybody understands how these are environmentally determined, the base grades. We all know that they're bumped for traffic and loading, but the problem here with the current system, it was kind of an add-in late. In order to get that bump, they're just asking for additional stiffness at elevated temperature that's not realized in the field. That's just as unfortunate that they had to do it that way, I guess, but that was a quick fix for an answer that they didn't have at the time. And again, this allows for products and processes that what I say can affect performance. Whereas with the multiple stress creep recovery process, we have this bump, increased stiffness at service temperature. Hello, that seems like a kind of a no-brainer to me. And then the other thing is that these types of products and processes kind of ensure the performance. Is what maybe that's a bold statement or bold proclamation, but that's my belief. Back to the grading. Here's how our state is set up currently. I mentioned that already. Here's our 6 grades. We're not going to see a proliferation of grades of asphalt in our state. We're going to see the same 6 or primarily 5 because, at least on the west side, most all of our suppliers and asphalt contractors have done away with 58 minus 22. Some of you are able to produce a product that met dual grade, so we can meet both. So we really don't see much 58 minus 22. If we moved into what the current M320 materials are, at least for our state, we'd be moving into the 58, SH and V, and really I'll show you another slide. Almost everybody, we're almost not seeing a need for S. Everybody's far exceeding that 4 on the JNR. Everybody seems to be more than capable of producing these products below 2. So that's another thing we're running into. There's no E there, which that was kind of the newest add-in to the specification. Right now, we don't see that we would use that in our state, unless it was in some areas perhaps like Port of Tacoma, where you have a lot of standing extremely heavy for that very obviously the E. There may be applications where it's warranted or necessary, but at least from a state highway standpoint, there's not too many places you would need that. And back in 2013, just show you a little bit about what we saw. And this is before we really were moving and doing a lot. This is our first year in the elastic recovery. Technically, I guess it'd be our second year of implementing elastic recovery. Here's what we're seeing. Not one of these, if you look at the heading, again, it's off the chart. The 4 is way over here. This is 2 kPa. So everybody's far exceeding. We're just not seeing anybody that's having a problem meeting an H with just the material coming out of the gate or out of the tanks. But there obviously is a few that are not meeting the percent recovery as per M332. Every one of these products did meet the elastic recovery 60. So just a little FYI. It's just kind of a snapshot. Again, we have skeins and skeins of data that I've shared with the Pacific Coast Conference, and if anybody wanted to see the information, you're more than willing to contact me, and there's my email address, phone number. And this is that email address for those in our state that are interested in looking at those charts that show the projections or the forecast for our state in regards to tonnage, location, grade of binder, and that type of stuff. So with that, I guess turn it over to you.
Any questions?
Yeah. Cal. Okay.
This is Tom Rosenmeyer with Lehigh Technologies. I was wondering if you have any experience with rubber modified asphalt or hybrid systems?
I think everybody heard your question. Do we have experience with rubber? We don't specify what's to be used. I guess maybe that's a blind eye and maybe an advantage from our standpoint that we don't get into formulation. We're not anti-AR or rubberized asphalt. Many years ago, I remember working in the laboratory when that federal mandate came down. We shall use rubber, tire rubber, and we were faced with having to use it in ungodly manners. But I can remember some of the PBA6 GR. And I remember after pulling it out of my mixing bowl and I saw strings coming off, and I mean, you could have ran them across the lab and they never break. So I had the advantage of working with some early day rubberized products. We're not opposed to them, but we're not out actively seeking use of rubberized materials, mainly because, at least from what we've seen, it's been cost prohibitive. And that's really what it boils down to. I don't doubt they can perform. We've seen some great things. But at least in our state, it's kind of been one of those opportunities with, if industry really was interested and saw an advantage and wanted to pursue it, we would probably support it.
Anyone else? Joe, thank you again.
No.
Break. It's a 15-minute